Hello everybody, welcome to our review for Appendix B. You'll notice that this video is going to be very short. That's because a lot of what's done in Appendix B is done in Appendix A and Chapter 1. So if you're feeling really comfortable about how Appendix A and Chapter 1 went, you're on a good roll. These are the two that are kind of new to this appendix. If you have not looked back, maybe you want to go back and rewatch or look at, for the first time, Appendix A and Chapter 1. All right, so let's talk about these two problems that we have. They ask us to simplify, and we've got one where we've got an exponent, so we've got our expression raised to an exponent, and then we've got one that's one expression divided by another. So let's kind of see how we can simplify. With this one, we're going to take in this exponent and we're going to distribute it to everything. When we do that, we'll have 2 squared times x, and then remember with exponents we're just multiplying them, so that's going to be x to the 4th. Then for our y, 2 times 6 is going to give us 12, and z is to the 1st right now, so we're going to square it. When we simplify it, because you'll notice we haven't fully simplified, we'll end up with 4 x to the 4th, y to the 12th, and z squared. And that's all we need to do to take and simplify this one. And the other one, we're interested in really just pulling out the greatest common factor and leaving it from there. So if we look at our 18 and our 9, we can take out a common factor of 9, which is going to leave us with a 1 below and a 2 on top. Then we look at our x's. We've got 1 x below and we've got 2 x's in the top. So we can take out one of those x's, which is going to leave me with 1 up in the top. Then we look at our y's. We've got 12 y's down below and 6 y's on top. So all of our y's on top are going to go away, and we'll be left with 6 down below. And our z's. We've got 1 z up top. Don't forget that's really z to the 1st. And we've got 3 in the bottom. So the 1 on top is going to go away, and we'll be left with 2z. So when we rewrite this, we will have 2x, or x to the 1st, over, we've got 1, which we could write, except we're also going to have our y to the 6th and our z squared. So just being able to understand really what it means to pull out these greatest common factors, how you want to find that one-to-one matching. A lot of what we've been talking about now, but just with single variables and not quantities. Hopefully that one makes sense. And we will continue on to our last one, which I think is probably the most difficult part from Appendix B, a little bit more complicated. It says the table below represents an exponential function of the form y equals a to the bx. So we're really dealing with exponentials. So you have to make sure you understand that equation, how it works, what the a represents, what the b represents, and what the x represents. So we want to finish our table, and we also want to write the equation in the form y equals a b to the x. So if we're filling in that table, we want to try and figure out the pattern. We know that we're talking about something that's geometric, and so therefore it's going up by some type of multiple. But we don't really know what that is right now. We know, so when we don't know what something is, we leave it as a variable, which is our x. So with this one, what we're looking at is we're going to take our last, one we went to, which was that 648, divide it by 3, and then we had 3 different x's, and so we're going to end up taking the cube root of this. So what we end up doing is we're going to take the cube root of 216, which we find out is equal to 6. So we're looking at 6, so we know that we're really just multiplying everything by 6. So we did 3 times 6 is going to give me 18. 18 times 6 gives me 108, and then we should be able to check ourselves. 108 times 6 gives me 648. So that checked out. Awesome. We filled in our table, and so now we want to write our equation. So we're trying to figure out what y is equal to. We need our a represents our starting value, which we know happens when our x is 0. So our starting value is 3 times what is our multiplier? What's that thing that makes it change or go up by every time? Which we find out to be 6. And then to whatever power we need to raise it to. So our equation is going to be y equals 3 times 6 to the x. That concludes all of the new stuff from Appendix B. Again, you might want to go back and look at Appendix A or Chapter 1 for more help. But if you can do this problem, I think it's the most challenging portion on our Appendix B. All right, good luck. Happy studies.